The next time you're, hanging out in a massive sports bar looking at dozens of 4K TVs perfectly synced up, take a close look at the walls.
You definitely won't find a single long HDMI cable in sight.
Right. In fact, that whole multi-million-dollar setup is probably running on the exact same cheap Ethernet cables you use for your home Wi-Fi.
It's pretty wild to think about.
It really is. So today, our mission for this deep dive is to uncover the hidden technology making these flawless video networks possible. We're using the technical spec sheet for the Hall Technologies UltraAV Extender series as our guide here.
Which, it really is a masterclass in overcoming the physical limits of moving massive amounts of data in the real world.
And let's start with that physical limit, right?
Yeah.
Because pushing 4K video over a standard HDMI, it's like trying to shoot a waterfall through a garden hose.
That is a very accurate way to put it.
The further it goes, the more the signal just degrades until the TV basically gives up and gives you a blank screen. So how does this UltraAV system actually solve the distance problem?
Well, standard copper HDMI cables degrade rapidly over distance, mostly because the signal isn't protected against interference. So the UltraAV series bypasses that entirely.
Oh, by taking that massive video signal and pushing it over a standard CD6 Ethernet cable.
Exactly. CT6 works where HDMI fails because the wires inside are twisted together in pairs.
Like the twisted pairs.
Yeah, and that physical twist actually cancels out electromagnetic interference. They call it crosstalk.
Interesting.
So it essentially packages the video data into these shielded streams that can travel a full 100 meters.
Which is what, like 328 feet?
Exactly, 328 feet without losing a single pixel of quality.
And there's a fascinating trade-off in the specs to make that distance work. The system pushes up to 4K Ultra HD at 30 Hz or 1080p at 60 Hz.
Right, you get a choice there depending on the use case.
Yeah, so you can choose the massive 4K resolution for like really sharp digital signage, but you trade a little frame rate smoothness.
Or if you're broadcasting a fast-paced football game, you dial the resolution back to 1080p.
To get that buttery smooth 60 frames per second.
You got it. And that flexibility is just key when scaling a network. The spec sheet actually outlines a few sender models, the 1S, the 4S, and the 8S.
Which distribute that signal to 1, 4, or 8 remote screens, respectively.
Exactly right.
Okay, let's unpack this for a second. We solved the distance problem for a few screens, sure. But what if my hypothetical mega sports bar needs, 50 screens?
Right, a lot more than 8.
Yeah. If we're scaling up beyond that 8S model, does that mean running 50 separate HT6 cables all the way back to the main source?
No, and honestly, that would be an absolute logistical nightmare.
That's what I was thinking.
So every sender in the series features a local HDMI loop output.
A loop output?
Yeah, you use that loop to daisy chain the signal from the first sender directly into a second one.
Oh, wow.
And then into a third, and so on. You can essentially expand the network infinitely from just a single source.
Wait, hold on. If we're daisy chaining these units endlessly like that, doesn't that introduce terrible latency? Like if I'm watching a live game, is the 50th screen on the daisy chain going to cheer a full second later than the first screen?
You would think so, but no. That is the genius of the engineering here. The loop output acts as an active pass-through with zero latency.
Zero, really?
Literally zero. The data is duplicated at hardware speed before it's even processed for the remote screens.
Okay, so screen 1 and screen 50 display the exact same frame at the exact same millisecond.
Precisely. And perhaps the biggest real-world advantage of this architecture is that the system requires absolutely zero video calibration.
Oh, man. Imagine installing 60 TVs and having to manually adjust the latency, color, and resolution on every single receiver.
While balancing on a ladder with a tiny remote.
A total nightmare. So zero calibration just means the installer plugs in the CT6, the screen instantly syncs, and they go home.
It turns a week-long nightmare into a one-day job. And that industrial reliability really is the defining line between consumer tech and this kind of hardware.
Right, because the spec sheet lists a mean time between failures, an MTBF of 90,000 hours.
Which is incredibly high.
Meaning you could plug this receiver in today, leave it running 24 hours a day, 7 days a week, and it wouldn't statistically fail for over 10 years.
Yeah, it's hardware designed to be installed and then completely forgotten about. It's backed by a solid metal enclosure and a 3-year warranty, too.
Truly a set-it-and-forget-it situation. And while you might not be dropping $926 on the UltraAV receiver for your living room anytime soon.
Probably not today.
Understanding this gives you an entirely new appreciation for the infrastructure seamlessly running around us.
Absolutely.
But it leaves us with something really important to think about. If this system is already working so hard to package massive 4K video files just to push them over standard CD6 cables, what happens next?
That is the big question.
Right. As 8K or even 16K video inevitably becomes the new standard, how will the physical limitations of these copper cables force us to completely rethink data transmission all over again? Are we going to finally hit a wall that twisted wires just can't climb? Think about that the next time you're looking up at a wall of TVs.